In the fern-draped floodplains of the late Jurassic, a silent giant stirred. Towering over the conifers and cycads, Barosaurus was a sauropod of staggering proportions. While its cousin Diplodocus often steals the spotlight, Barosaurus may have possessed the longest neck of any known dinosaur. Its vertebrae, each one a masterstroke of evolutionary engineering, stretched like a suspension bridge across time, allowing it to browse treetop foliage with a simple, elegant sway. Though fossils are few and often fragmentary, paleontologists have reconstructed its grandeur from scattered clues: a whip-like tail, powerful limb bones, and a neck that seemed to test the limits of anatomy itself. This wasn't just a large animal, it was a vertical marvel, designed for reach, efficiency, and grace. Barosaurus wasn't built for speed. Weighing over 40 tons, haste would have been unnecessary, and probably impossible. But what it lacked in agility, it made up for in strategy. Its extraordinary neck allowed it to feed across wide areas with minimal movement, conserving energy in a world it shared with other megaherbivores. Some paleontologists propose that it could rear up on its hind legs, using its tail like a third pillar to balance, a maneuver that could have extended its reach to nearly 15 meters high. If accurate, this would have let Barosaurus tap into treetop resources inaccessible to other dinosaurs, carving out an ecological niche in the upper canopy. And yet, for all its grandeur, Barosaurus remains something of a shadow in the fossil record. Most of what we know comes from a handful of specimens uncovered in the Morrison Formation of North America. The most complete find, a partial skeleton and an almost full neck, has provided critical insight into its physiology and lifestyle. Still, many questions linger. How did it support such a massive neck without collapsing under its own weight? What kind of cardiovascular system could sustain blood flow to such lofty heights? These enduring mysteries drive scientific curiosity forward, a reminder that even Earth's greatest giants often leave behind only fragments, and that within those fragments, entire worlds of discovery still await. Supporting a neck that could stretch more than 9 meters into the air wasn't just an engineering challenge, it was a biological conundrum. To push blood to such heights, Barosaurus may have needed a heart unlike any seen in today's animals, possibly one massive, powerful pump, or even multiple hearts working in tandem. Some estimates suggest that Barosaurus lentus, measuring around 26 meters long and weighing 20,000 kilograms, might have required an arterial blood pressure of 100 millimeters of mercury, driven by a left ventricle weighing about 72 kilograms with a wall thickness of over 8 centimeters. These extraordinary cardiovascular demands continue to puzzle scientists. Some theories propose intricate valve systems within its arteries, others suggest it held its neck more horizontally to reduce the vertical pressure load. While no soft tissue has ever been found, the vascular mysteries of sauropods remain one of the most captivating, and unresolved, chapters in dinosaur physiology. Barosaurus didn't roam a quiet world, it lived among titans. The Morrison Formation was teeming with life, massive sauropods like Apatosaurus and Camarasaurus, stegosaurids with spiked tails, and carnivores such as Allosaurus stalking the edges of herds. In this ancient ecosystem, Barosaurus had to compete for food and space, yet its unique neck likely gave it an advantage. By reaching where others couldn't, it fed from untouched foliage, reducing competition. This vertical niche partitioning helped multiple giants coexist in relative harmony. Rather than conflict, evolution favored specialization, a towering herbivore designed to rise above the rest. Predation was always a threat, even for a dinosaur as large as Barosaurus. Allosaurus, the apex predator of its time, hunted in packs or opportunistically ambushed weaker individuals. Yet Barosaurus's immense size and communal herding likely offered protection. Young or injured individuals may have stayed closer to the center of the group, while adults formed a mobile fortress. The possibility of a whip-like tail only added to its defense. In life, size mattered, but so did numbers. Fossil sites showing mixed herds support the idea of sauropods moving together, not as loners, but as coordinated giants shaping their world. The Morrison landscape was seasonal and shifting, precipitation filled rivers that carved through the land, water cycled through evaporation and infiltration, and vegetation thrived or withered as droughts lingered. Though volcanoes rumbled in the distance, it was the ever-turning water cycle that shaped life below. Barosaurus had to be resilient, capable of long treks in search of food or safer ground. Its long neck wasn't just for vertical browsing, it may have helped skim the horizon or navigate dense forests. Survival here demanded more than strength, it required awareness, endurance, and adaptability. Every step of this sauropod stirred the earth, leaving tracks that would fossilize into lasting echoes of an age when the ground trembled beneath living mountains. To understand how Barosaurus could grow so massive and yet remain mobile, we must look beneath the skin, at its bones. Sauropods like Barosaurus evolved a remarkable skeletal feature: air sacs within their vertebrae. These hollow chambers, part of an intricate respiratory system, lightened the load without compromising strength. Rather than solid bone, its neck was a lattice of struts and air, allowing it to stretch skyward without snapping under its own weight. This adaptation, called pneumaticity, is also seen in birds today, a clue to their distant ancestry. Each vertebra was a fusion of strength and efficiency, enabling a neck longer than a city bus to flex and lift with surprising ease. But bones alone didn't make Barosaurus extraordinary, it was the harmony between structure and function. Its cervical ribs, long and overlapping, likely acted like tension cables, stabilizing the neck during feeding and movement. Muscles anchored deep along the neck's length would have contracted in coordinated waves, allowing graceful motion even in such a colossal frame. The tail, conversely, was a counterweight and possibly even a defensive tool. Some paleontologists argue it could crack like a whip, deterring predators with sonic bursts. Every piece of Barosaurus's anatomy, from skull to tail tip, tells a story of evolutionary innovation, a body engineered not just for size, but survival. Perhaps most astonishing is how little remains of Barosaurus, and yet how much we've learned. The famous neck specimen at the American Museum of Natural History towers above visitors, posed in a dynamic rearing display that brings its biomechanics to life. Scientists have used scans, digital modeling, and comparative anatomy to reconstruct missing parts, often borrowing clues from better-known relatives. Now, researchers debate the details: how flexible the neck truly was, or how many heart chambers it needed. The fossils may be silent, but the questions they raise continue to echo through labs and museum halls alike. Not all dinosaur stories are written in stone, some are nearly lost to time. In the early 20th century, a partial Barosaurus skeleton was unearthed in the rugged canyons of Utah's Dinosaur National Monument. Nicknamed Gordo, this specimen was enormous and tantalizing, hinting at great scientific potential. But it was far from complete. With limited funding, competing excavations, and the challenges of the era, Gordo's remains were boxed up and shelved, left unprepared and largely forgotten in museum storage for decades. Only a few fragments ever saw the light of day. Yet among paleontologists, Gordo lived on as a kind of mystery, a half-told tale whose massive vertebrae whispered of an unusually long and possibly record-breaking Barosaurus. For years, it waited in the dark, an unfinished puzzle suspended in time, but rediscovering Gordo decades later would spark a fresh chapter in a story long thought dormant. By the 1990s, a renewed wave of interest in sauropod dinosaurs and significant advancements in research tools brought Gordo back into the spotlight. After decades in storage, the long-forgotten bones were finally exhumed and given the attention they deserved. With the help of CT scans, 3D modeling, and modern skeletal reconstructions, scientists could study Gordo in ways that were once unimaginable. What they found was astonishing: vertebrae among the largest ever attributed to Barosaurus, suggesting an individual that may have stretched even longer than previous estimates. Though the skeleton remained incomplete, there was now enough evidence to fuel new scientific interpretations and spark the creation of public exhibits. For the first time, Gordo's legacy moved beyond storage drawers and dusty labels. Once a quiet artifact of the past, the specimen became a striking emblem of paleontology's evolving nature, and a reminder that science often circles back to old discoveries with fresh eyes. Gordo's journey isn't just a tale of fossilized bones, it's a story about persistence, curiosity, and the enduring power of unanswered questions. As museum-goers today stand beneath towering mounts built from his vertebrae and bones from similar giants, they're witnessing more than a reconstruction, they're seeing the resurrection of a ghost from the Jurassic world. Gordo's story reminds us that science is never truly finished. Each overlooked crate, each mislabeled fragment in storage might still hold secrets waiting to be revealed. And sometimes, the most profound discoveries aren't made out in the field under the blazing sun, but quietly, years, even decades later, within the still, dust-covered archives of human knowledge. In that sense, Gordo is more than a dinosaur, he's a symbol of what science can become when it's allowed to revisit its past. Barosaurus may not be as famous as some of its Jurassic cousins, but its graceful neck, towering stance, and gentle presence speak volumes about the diversity and wonder of the world it once walked. As we continue to uncover ancient bones and piece together ancient lives, Barosaurus reminds us that even in the age of giants, there's always more to discover, and more to marvel at. Thank you for joining us on this journey through deep time, and have a joyful day.